Today, we are going to start out with a division problem. Happens to be number 4A. So I'd like you to focus on 4A on your paper. Grab your pen and pencil. And we're going to employ the idea of skip, change, flip because we're dividing two fractions in algebra. I'm circling the divide sign to remind us to skip, change, flip. Now we're going to cheat a little. And instead of just skipping over the first fraction entirely, we're going to leave a little space, because we have space, and we're going to, at the same time, factor the numerator and factor the denominator. Now, the first numerator is a binomial. When you factor binomials, you have a couple different techniques you can use to factor. When you factor a binomial, it might be the difference of squares, which is generally easy for students to use, or it could be the case that there's a greatest common factor to pull out. And remember, when there's there are letters involved, the greatest common factor when there's letters is the one with the lowest power on the letter. So 5x cubed and negative 10x squared, we can make a fraction bar, and we can pull out a 5. And between x cubed and x squared, they have two factors of x in common. So we've got 5x squared times the quantity. I might have to extend my fraction bar a little bit, which is okay. Times whatever's left over when I divide 5x squared into each of the first two terms. And one way you can think of that is to think 5x squared times what? I'm making an arc. I'm distributing inside. 5x squared times what makes 5x cubed? Well, we've got the 5. Down here we've got two factors of x. We need three factors of x, so we need an extra factor of x. So you can check to see if you factored out the GCF correctly by redistributing the GCF inside the parentheses. Are you with us there, Brandon? Okay. 5x squared times x will make 5x cubed. Drop down your connector sign, your subtract. And then think 5x squared times what, go back up to the top, makes 10x squared. Well, we already have the two factors of x we need. We're lacking a factor of 2. So close off your parentheses and think 5x squared times negative 2 does give us negative 10x squared back that we started with. Now we'll factor the denominator of that first fraction that we're really skipping over. And we see that between 10 and 40, 10 is the biggest number that goes into both 10 and 40. And between x squared and x to the first, they have an x in common that we can factor out. So it's 10x times the quantity. All right, when we divide x into x squared, we're left with an x, and that checks out. 10x times x makes 10x squared. Then bring down your connector sign, plus, and then 10 times 4 will make 40. And a common mistake students make is to tack an x on the back of 4. We don't need it, because we already have in 10x an x that we need to make 40x. So we close off our parentheses. So we're done factoring the numerator and denominator of the first fraction that we're skipping over. Now we're going to change divide to times, and then bring over a fraction bar, and then flip the fraction we're dividing by. Now here again we can sort of cheat and look at the denominator that now has to become the numerator. So x squared plus x minus 12 is what we're going to factor and put its factors in the numerator. Now I had both my mod 1 and 2 stumped today. When I mentioned leading coefficient, look up at the screen right now. If I asked somebody what the leading coefficient of x squared plus x minus 12 would be, you might be stumped until I put that, what did I put in?
1.
1 in. So when the leading coefficient's 1, when I say that, good things happen. It's easier in more than one way to factor that trinomial. Not only do you have a set of parentheses here and here, and the only way to undo x squared is x times x. And you look at the last sign, which is a negative in front of the 12. Remember, we're looking at the denominator because it's becoming our new numerator. The last sign's negative, means the signs are different. When the leading coefficient's 1, it doesn't matter whether you put the plus first or the minus first. because they're both just x's, right? Okay? And another plus, a good thing that happens when the leading coefficient is 1, is that we're looking for factors of 6 that add to 5. Notice I'm going backwards. They've got to be 3 and a 2, right? 3 times 2 is 6, and 3 plus 2 is 5. Well, here, we don't have to check the inners and outers when the leading coefficient is 1. The bigger factor is going to get the middle sign. And I think I mistakenly looked at the wrong trinomial, didn't I? Yeah. I should have been looking at the 12 down there, right? Okay, so factors of 12 that subtract to 1, wouldn't they be 3 and 4? Yeah. So the bigger factor, we get the middle sign, so the sign in front of the x that I'm making my pen dance over right now is a plus. So it's got to be x plus 4 times x minus 3. Now you always can check that your outers and your inners, and I call that the forehead and the smile because that's what that looks like to me. Your outer products and your inner products combine to make the middle. Negative 3x and positive 4x do make that positive x in the middle, so we know we factored it correctly. So now we're going to factor x squared minus 5x plus 6, which is even more of a gift. Besides having a leading coefficient of 1, the last sign is a positive, which means the signs are the same. They're either both positive or they're both negative. That's when you look at the middle sign. And the middle sign here is negative, right? We're looking at the numerator that's going to become the denominator, so they're both going to be negative. So factors of 6 that add to 5 got to be 2 and 3. Now, what a hint, really. Those people that aren't good at factoring, this unit is a good one for you because it gives you hints. We've already got an x minus 2, so maybe we're looking for an x minus 2 somewhere else, right? Either diagonally or up and down. Now, even if you have like 3 fractions that you're multiplying together, or you're dividing the last one off, you can go from a denominator way over here to a numerator way over here in a fraction. Okay? They're all connected by times. Eventually they will be in this lesson. Okay? Okay, so now that we've skipped, changed, flipped, and factored along the way, we can cancel like factors. Now this is the part that's hard to recreate. I'm going to change colored pens, and you might want to do that too. Do red pen to pencil, show a little contrast there. I'm going to make a mistake that I made in the morning class because I can see other students doing this too. Now we're building a level above and below these fractions. I'm going to very lightly cross out a factor of x minus 2 on the slant with a factor of x minus 2 on top and put 1s in their spots so I know I took care of them. And then I'm going to cross cancel an x plus 4 with an x plus 4. And now I'm eyeballing the x and the x squared. Now x's are tough to show how to cancel because part of an x is already slanted anyway. That's when contrast really helps. We have 2 factors of x on top, x times x, and 1 factor of x on the bottom. That's like having x times x, x squared, all over x. Look what would happen. A pair of x's would go, we'd be left with 1 factor of x on top, wouldn't we? Yes, thank you, Michael. So we're going to cross out x on the bottom with x squared on top, and we're going to write that we're left on a new level. We've risen to a new level, and x on top. We're going to be left with him. Now we can cross cancel the coefficients up and down. And this is called reducing. Reducing a fraction. 5 over 10 reduces by 5. Now, common mistake I've seen people make because they do too much in their head. 5 goes into 5 once, 5 goes into 10 twice. But I've seen people cross out the 10 and put a 5 down there. And I know they have the right idea, but you got to be careful. You're dividing 5 into both. So we get a 2. Now, I was ready this morning to circle the 2, and then I went back through, and I was ready to call the answer x times the quantity x minus 3 because I hadn't done anything with this x minus 3 over here. But there's 1 on the bottom, right? Correct. So that circling helps you identify when you scan through to make sure you canceled everything. The circling should help you. So we can cancel a factor of x minus 3 in the top and the bottom. So now we're left with an x on top and a 2 in the bottom. And this might be a multiple choice question. Leave a space to give yourself a lot of organization in your work. And if x divided by 2 isn't an answer, you have to be willing to admit, to realize that dividing by 2 is the same as taking a half. And we want to go and show fractional coefficients most of the time when we work with polynomials. So if I throw a 1 in front of the x, that's the same as having only a half of x, equivalent to that big monster problem we had at the beginning of what we did. Okay? So that's the final answer, a half x. So now what I'd like you to do is go and turn to the front page and look at a problem there with me. Let's look at 2a. We're looking at 2a. We notice that a, b, c, d are all multiplying fractions. We do not need a lowest common denominator to multiply or divide fractions. We have to factor first and then cancel. And that is something you can communicate with your study partner. When we multiply fractions, Bob, Mary, your study partner, whoever they may be, when you know what? When we multiply fractions, we have to factor first and then cancel. When we divide fractions, Bob or Mary, that's when we think skip, change, flip. It's good to talk to people. This is good supper conversation. What you do in school today? Skip, change, flip. What does that mean? Yes. Fred or Martha? Okay. Yes. Thank you for that, Matt. There's a whole gamut of names that you could have possibly as students in your classes, all right? I'm on purpose not using names in here because I don't want to single anybody out. Okay, so we're focusing, we're spotlighting what, Lindsay? What question are we working on? 2a, excellent. So we're going to factor first and then cancel. So I'm going to make my fraction bars first, anticipating a nice amount of space to show my work. And I'm going to dig right into my favorite kind of polynomial to factor. It's the difference of squares. 9x squared minus 16. Parentheses times parentheses. Should be a 3x times a 3x. A positive times a negative to make that middle connector sign a negative. And then a 4 times a 4. And there's our hint. Wouldn't it be wonderful if we had a 3x plus 4 or a 3x minus 4 somewhere in either of the two denominators that are now vacant? Okay, now I'm going to dig right into my second favorite binomial to factor, where I take out a GCF. So I have a choice. There's two of those kind of binomials. I'm going to stick with this front fraction. 12x and 16, I can't take an x out. They don't both have an x, but they do have a factor of 4 that will go into 12 and 16. In fact, that's the biggest factor that goes into both. So when I factor out a 4, lo and behold, I have one of those factors that I was hoping to get. 4 times 3x will make the 12x that I started out with. I got to remember to bring down that connector sign, plus that you can reinforce with your study partner or study group. 4 times 4 makes 16. So even though I really want to be able to cancel something right now, I'm going to hold back. I'm going to factor first and then cancel. I'm going to go for my that other favorite that I like, that 8x plus 8. I'm going to take an 8 out. I'm going to be left with an x plus 1. So maybe if we're lucky, we're going to get a 3x minus 4, an x plus 1. In the denominator of the fraction denominator that's vacant. So here's a trinomial whose leading coefficient is not 1. What's the leading coefficient of 3x squared minus x minus 4, Jack? A 3, good. So the only way to unfoil, luckily 3x squared, because 3 is a prime number, is 3x times x. Uh-oh. That last sign is negative in front of the 4, means the signs are different, and because the leading coefficient is not a 1, we can't put the signs in yet. They're going to be different. We don't know where they go. Now we're going to make our forehead. Everybody do that on your papers, please. The outers is what represents the forehead. And the inners, make the smile, have to, okay, watch the dancing pen up above. They have to subtract to 1. So numbers that multiply to 4, let's see, 4 times 1. If I put a 4 here and a 1 here, okay, here's the forehead. What's 1 times 3x, everybody?
3.
I heard Michael. 3x, thank you. And 4x, do they subtract to 1x? Yes. And which is the bigger, 3 or 4?
4.
So we put the middle sign, which is a negative, in front of the 4, and a positive here. And lo and behold, I change my colored pen, make a little contrast. I have a pair of 1s, x plus 1s I can cancel out. A pair of 3x minus 4s I can cancel out. I'm building a new level up in the top and bottom. A pair of 3x plus 4s I can cancel out. And I can reduce the 4 and the 8, the coefficients, by 4. That means I divide 4 into each. 4 goes into 4 once, 4 goes into 8 2 times, and I think the only thing we're left over with is a who?
2.
A 2. Thank you for the fingers. Very good. The peace sign, 2. Now that monster multiplication problem reduced down to a 2. Not bad, huh?
Not bad at all.
All right, now go to your back page, please, and look at the problem that started out with division. It's multiple choice, isn't it? Number 3. Now, does multiple choice mean we just guess at an answer? Okay, we better get the video camera out. Camcorder. Or not? I wouldn't do that. No. Well, what kind of response do I want? Multiple choice. Does that mean we show no work and just guess?
No.
No. It means we have to show work in the space provided, just like we're going to do in our Algebra 2 and Trigonometry regions, right?
Right.
So this divided by means, what are you going to tell your study partner? When we divide fractions, we skip, change, flip. Yes?
Yes. Yeah.
And then it reduces it to a multiply problem, and then we factor out and then cancel out. Okay, so I think we're okay with number 3. Let's go up to number 1. Okay, 1, A, B, and C. Monomials. I'm going to go to my red, since the problems are in black. I'm going to cross-cancel the coefficients first. Now, you can do these in any order you like. This is what's hard to reconstruct. So think about how you might do it, but you're okay just to watch me, okay? I like to think, okay, the 5 goes into the 15 evenly, 3. And then I'll make the 5 go away. So I'm going to cross out the 5. 5 goes into 5 once, 5 goes into 15 3 times. And then I'm staring at a 3 and a 12, and I know I can never, ever, ever cross the 3 with a 12 because they're on the same horizontal line, aren't they?
Right.
All right, but 3 goes into 30, and then the 3 will go away. Why not cancel the 3 with a 30, right?
Right.
Yeah, so 3 goes into 3 once, 3 goes into 30 10 times. Good so far?
Yeah.
Okay. Now, 10 and 12. 10 won't go into 12, but what's the biggest factor that will go into both?
2.
A 2. 2 goes into 10 5 times. 2 goes into 12 6 times. So it's looking like I'm circling a 6 on top as a coefficient, divided by a 5 on the bottom. Now I'm going to go to black, and I'm going to cross-cancel the x to the 4th with the x squared, top and bottom. Where do we have more factors of x, and how many more of them do we have? We have 2 more factors of x on top. So to show that, we say x squared goes into x squared once, and x squared goes into x to the 4th x squared times. X squared means x times x. There's two factors of x there. Not 2x. And I know that sort of looks like an x with a 2 in back of it. It was meant to be an x with a flying 2. That's x squared. X squared. Okay, now y divided by y to the 8th. We have 7 more factors of y in the denominator. And we're not getting any tickets here because there's no super glue gluing the terms together with adds and subtracts, correct? It's all factors that we're canceling out like factors. So we're going to say y goes into y once, and y goes into y to the 8th, y to the 7th times. So it looks like we have x squared that I'm circling on top, and y to the 7th I'm circling on the bottom. Now, just like in arithmetic, you make that equal to what you get when you multiply what's left over straight across the top. 6 times x squared times 1 is 6x squared. Divided by, what are we going to put on the bottom? Jimmy? We're left with a y to the 7th, a factor of that, and a 5. So when we multiply those together, what will we get? Jimmy? Go back? Go back to which part? You forgot? Do you understand how we got the 6x squared there?
Yeah.
Okay, my pen is sort of hanging over that. 6x squared, you got that?
Yeah.
Okay, and we cross-cancel the y with the y to the 8th, and we're left with y to the 7th down there?
Yeah.
Okay, and we already had a 5 down there? You know how we got that?
Yeah.
With all the coefficient canceling? So all you're doing now is multiplying straight across the top. 6 times x squared is 6x squared, divided by, now we're waiting on the bottom. 5 times y to the 7th is just, it's that easy, okay? Okay, good. Don't leave us hanging if you don't get it. Ask questions, okay? Good. 5y to the 7th. Any questions? Okay, you may use the next 5 minutes, the whole 5 minutes, to finish that worksheet. Please.